For decades, we have lived in two separate dimensions of reality: the digital world built by software and the physical world composed of steel. Cars, robots, airplanes, all have been nothing more than cold machines executing commands. But what if this separation is about to end? What if a powerful general artificial intelligence could seamlessly control cars, robots, and aircraft? What if these machines could independently learn, continuously evolve, and collaborate in our real, complex world? This is not a fantasy. This is physical AI. Today, we are taking you inside XPeng's 2025 AI Day. This was not just a product launch. It was a declaration of a new philosophy, where AI breaks free from screens and learns to walk, drive, and fly alongside us. Before we dive into the technology, we need to understand the one word that defined this entire event: emergence. It's a concept from complexity science, and it's crucial to understanding XPeng's vision. Emergence is the phenomenon where a system develops complex, intelligent behaviors that are not present in its individual parts. Think of it this way: a single ant is a simple creature, but a million ants, through simple interactions, can create a complex, intelligent superorganism, the colony. A single neuron is just a cell, but billions of neurons, when connected, give rise to consciousness. In the world of AI, emergence happens when you feed a large model a massive amount of diverse, long-tail data. You compress it, you let it find patterns, and suddenly, it starts displaying abilities you never explicitly programmed it to have. It emerges. XPeng's CEO, Xiaopeng, argues that we are at a moment of technological emergence. Their decade-long, full-stack, in-house development in cars, robotics, and flight, once separate endeavors, are now beginning to cross-pollinate and merge. And their massive data-driven AI is starting to show emergent capabilities. This Tech Day was about showcasing that emergence. The first and most profound announcement was in the realm of autonomous driving. XPeng declared the arrival of their second-generation VLA, Vision Language Action Architecture, which they believe is a fundamental paradigm shift. To understand its importance, you need to know how most end-to-end AI driving models work today. They follow a vision-to-language-to-action path. The car's cameras, vision, see the world. The AI then translates this complex visual scene into human-like language or labels. There's a pedestrian, a red light, a car cutting in. Then, a second part of the AI takes this language, and, based on human driving rules, decides on an action. Xiaopeng argues this is fundamentally inefficient. It's like trying to describe a beautiful, complex painting using only words. A huge amount of information is lost in translation. He showed an example of a 10-second video clip that required 1,200 words to describe inadequately. XPeng's radical new approach is to build a true vision-to-action VA model. It's a leap of faith based on first principles. The goal is to eliminate the language middleman. The AI sees the world and directly translates that rich visual data into driving actions, just like a human driver does. We don't consciously tell ourselves, a car is merging, I should decelerate by 10%. We see and we react. This, they argue, is the beginning of a true physical world model. This path was incredibly difficult and expensive. Xiaopeng candidly shared their journey of failures. They invested over 2 billion RMB, about $275 million, and used a supercomputing cluster of 30,000 GPUs, burning through millions in cloud computing fees every single month, with almost no results. The project was on the verge of being canceled. And then, one day in the second quarter of 2025, emergence happened. The model, after months of failure, suddenly woke up. It went from being completely unusable to demonstrating moments of fluid, human-like driving in complex scenarios. The engineers were stunned. At that moment, they made a high-stakes decision. They stopped all development on their old, more predictable VLA model and went all in on the new VA paradigm. The results are astonishing. The system can now navigate small roads and campuses, the complex, unstructured environments that are the ultimate challenge for autonomous driving. This is what's needed to truly conquer global markets, especially in the narrow, historic streets of Europe. In a head-to-head comparison with the latest version of Tesla's FSD in a 20-kilometer complex urban route, XPeng's system required only 1/5 of the human interventions. Even more fascinating are the emergent behaviors. The system, without being explicitly programmed, has learned to stop when a pedestrian waves at it. It has learned the subtle human behavior of creeping forward in the final seconds of a red light. These are not coded rules. They are intelligent behaviors that have emerged from training on a massive data set of nearly 100 million video clips, equivalent to 65,000 years of human driving experience. XPeng has now made this second-generation VLA model, along with their self-developed Turing AI chips, available for licensing to other automakers, with Volkswagen announced as their first global customer. The second major emergence comes from the fusion of XPeng's AI capabilities with the physical world in a new form, the humanoid robot. He Xiaopeng shared their 7-year, 7-generation journey in robotics. They started, like many, with 4-legged robots. They were stable and powerful, but they quickly ran into two fundamental problems. First, they have no hands. A 4-legged robot is a mobile sensor platform, but it can't interact with a world built for humans. Second, they are clumsy in human spaces. Their large turning radius makes them impractical in a typical 100 square meter apartment. This led them to a crucial decision: to pursue the much more difficult, but ultimately more practical, path of a bipedal, humanoid robot. Why? Data. Our world is filled with video data of humans performing tasks. A humanoid robot can learn directly from this data. Environment. Our world, our homes, offices, factories, is designed for humans. A humanoid robot can navigate it naturally. Adoption. A machine that looks and moves like a human is less intimidating and more easily accepted as a companion or helper. The result is the new generation robot, Iron. It is an engineering marvel designed for mass production. It has a biomimetic spine, allowing it to bend over and touch its toes. A simple human action that is incredibly complex for a robot. It has modular muscles and flexible skin, allowing for customizable body shapes and genders. It features one of the most complex components ever put into a robot: a dexterous hand with 22 individual joints per hand, powered by micro actuators just 16 millimeters in diameter. And in an industry first for humanoid robots, it will be powered by a mass-produced, full solid-state battery chosen for its ultimate safety in indoor environments. So, where will we see Alan first? XPeng is taking a pragmatic approach. Not in factories tightening screws, a job still too harsh for today's delicate robotic hands and too expensive compared to human labor in China. Not yet in homes doing laundry, a task too complex and unstructured. Instead, they will start with the 3 guides: tour guide, shopping guide, and patrol guide. Starting in 2026, Alan will be deployed in XPeng's showrooms, factories, and service centers, acting as a guide, a brand ambassador, and a security patrol. These are structured environments where it can learn and provide real value. And just like their autonomous driving tech, XPeng is opening the robot's SDK to partners, with industrial giant Baosteel announced as their first ecosystem collaborator. The third emergence takes XPeng's vision of physical AI into the third dimension: the sky. Their subsidiary, XPeng Aero HT, has been working on this dream for 12 years. At the Tech Day, they unveiled two distinct paths to the future of personal flight. Path 1, Land Aircraft Carrier. This is the product closest to reality. It's a modular design, a 6-wheeled hybrid truck that carries a detachable, 2-person electric vertical takeoff and landing (eVTOL) aircraft. You drive to the edge of the city or to a scenic area, and then deploy the aircraft for the last-mile flight. It's designed for tourism and recreation. With over 7,000 pre-orders, it will begin deliveries in late 2026, making XPeng one of the first companies in the world to deliver a true flying car to consumers. Path 2, the Intercity Commuter, the A868. This is their more ambitious, long-term vision. The A868 is a 6-person, tilt-rotor, fixed-wing eVTOL. It takes off vertically like a helicopter, but then transitions to flying like an airplane. This hybrid design gives it a massive range of over 500 kilometers and a cruising speed of 360 kilometers per hour. This is not for sightseeing. This is a high-speed intercity air taxi. To support this vision, XPeng is building a network of 6S centers, sales, service, etc., plus flight, and is developing its own pilot training and licensing program, designed to be as simple as learning to drive a car using a single joystick and a screen. So, we have a car that can drive itself through the most complex urban jungles, a robot that can walk, talk, and interact like a human, and a machine that can both drive on land and fly through the air. They seem like disparate projects, but here's the final, most important piece of the puzzle. They are all powered by the same core AI. The VLA model that teaches the car to drive is the same fundamental technology that teaches the robot to walk and navigate. The VLM, Vision Language Model, that allows you to have a natural conversation with your car is the same model that allows the robot to understand your commands. And XPeng has introduced a new third model, VOT, a slow brain that handles reasoning, decision-making, and task decomposition for the robot's complex interactions. This is the essence of physical AI. It's the creation of a single, unified, world model-based intelligence that can be adapted and deployed across different physical embodiments. It's a platform, an operating system for the physical world. XPeng's 2025 AI Day was more than a product showcase. It was a bold declaration of a future where the line between digital intelligence and physical reality is erased. A future where our cars, our helpers, and even our personal aircraft are all nodes in a single, ever-evolving, intelligent ecosystem. It began with a spark of an idea, a glimmer of light, a dream of a car that could drive itself, a robot that could be a companion, a machine that could fly. As He Xiaopeng concluded, a single spark, through emergence, can reach for the stars. This is a future of incredible possibility, but it also raises profound questions. Now, I want to hear from you. This vision of a unified physical AI, controlling our cars, robots, and more. Does it excite you with its potential, or does it concern you with its implications? Which of these three emergences do you believe will change our world the most in the next decade? The self-driving car, the humanoid robot, or the flying machine? Join this incredible conversation in the comments below. If this deep dive into the future of physical AI has expanded your vision of what's possible, please give this video a thumbs up, subscribe to Volt China, and hit that notification bell. We are living through one of the most transformative moments in human history. Thanks for watching, and I'll see you in the next one.